Hello grade 11s. Today I'm looking at a new section. This is the first drawing of the curve of interpenetration, and this can be found on page 77 in your workbooks. So let's just read through the given information there. It says that the front and top view are shown. This is first angle orthographic projection. You've got a equilateral triangle as the main cylinder, and you've also got a triangle that's fitting into this shape. Okay, the axes of both prisms lie in the common vertical plane, implying that the center line from this main pipe is in line with the center of the branch pipe. Draw to a scale of 1 to 1 the given top view, the given front view. So this is somewhere where they can test, do you understand how to do constructions? And the left view clearly showing the curve of interpenetration, and then we've got to develop the surfaces of both prisms. Okay, so we're going to start by then constructing this shape, and then I'm going to project up and do the front view. I've constructed my equilateral triangle of the main pipe, a length of side of 44, and then I've drawn 60-degree lines to intersect. There's my center line. Then when I bisected my angle, so in other words at 30 degrees, going to that center line, that gives me the edge of where the branch pipe hits the shape, and they said that the length of that branch pipe was 44 as well. Mark off my distance of 44. And this gives us the outline of our top view. Now I'm going to go over that in dark lines. There we have our top view complete, and now I'm going to project my lines up to get the length dimensions for my front view. I've left a space of 15 between my views. Then they said our height here was 84, and the height from the top of my main triangular prism was 17 to where the inside triangle is. And once again, that was an equilateral triangle, so I'm just going to draw in from my length measurement, just get these to join up. And there we have the given front view, which I'm going to go over now in a dark line. Now the reason that they want us to do the left view is so that we can get the curve where the branch prism attaches itself to the main prism. Generally what they'll do is they'll rotate this shape so that you get to see the curve of interpenetration in the front view. So just like we would do with any left view, we're going to project height dimensions across from our front view, and we're going to project a 45-degree line in from the corner of our front view to project the width dimensions. Where they hit the 45-degree line, we're going to take them up. So at the moment I've projected all my lines across to the 45-degree line and up, and I've projected my height dimensions. So what I'm going to do now is just look at my outside triangle, my main triangular prism. So I like to label my points, so let's call this the ABC triangle. Now points A and B are at this height level, and C, because it's a prism, A, B and C at this height level. But if you follow them across, this is A and B, and this side here would be C. So there's my A and B side of the triangle going up to this point. Now, if we look at the main aspect of this, trying to work out the curve of interpenetration, let's take a look at how I'm going to do that. I'm going to label my shape of the triangular prism, that is the branch cylinder. Let's follow those points down. That would give me 1, this is going to give me 3, and this is going to give me 2. Now remember, where they hit, they also have different points. So if we follow them, here is point 1 and 2. So I follow points line for the lines 1 and 2, and I follow them up to where point 1 and 2 is. There is where 1 and 2 is hitting the main pipe. Where does 1 and 2 finish? They finish at this point over there. I've now joined up those points. So the remaining point that I need to find will be point 3. So where does point 3 hit? So point 3 hits the main pipe at this point, which if we follow it up and we follow our horizontal line across, is going to give us this edge. Where does it finish? It finishes here, over there. So the curve of interpenetration, and because these sides are straight, the curve is no curve, it's a straight line, would be from where 3 goes up to join 1, and it would be the same on the other side of the shape. So I'm now going over that in dark lines. This is now the completed left view showing the curve of interpenetration over there. Now, drawing the development means we want to fold open the shape. Now, the best place to do that is where you could use measurements off one of the given views. So for this case, our best place to draw the main triangular prism would be to project it off here, because we can take the height measurements off that shape, and the points we're going to have to get off a different shape. Now, for the smaller branch cylinder, the branch prism, this is actually the width dimension, but we could project that straight across here to get those measurements as well. So that would be the best option to do this. So I'm going to extend my heights across here and start with the main triangular prism. The true length of this main triangle was 44. Now, what we have to do is obviously mark off that true length of the sides. Now, what I want you to just do is check here. So if I check this distance here, you can see that this distance is 39. So that doesn't give you the true length of the side. So please just remember that. We can get here as the true length of A and B, B to C, that would be the distance of 44. Because A and B is that same distance there, you could take that measurement there. So what I need to do is mark off that main length of the side of 44, and I need to mark it off 3 times. Just to make sure that we know what we're doing here, I'm going to label off the corners here. So I'm going to start, there is corner A, there is corner B, there is corner C. Now remember, to complete the triangle, C has to go back to corner A, because that gives us 1, 2, 3 sides. So between A and B, there's no piece that has been cut out. Between B and C, we've got to find this little part here, and between C and A, we've got to find the distance to 1. We need to use this true shape. So what we need to do is measure the distance to find points 1 and 2 along these lines. Now because this shape is symmetrical, we just need to measure one side and we can mark it off the same on the other side. So here, if I take this distance with my compass, there is the distance from C to 1. It'll be the same, as you can see there, to 2. Now this is why I've marked it. So I now go to C and I mark off going towards B. That would give me point 2. At C, going towards point A is going to give me point 1. And I'm going to project that line up vertically. This is where I believe I call it the theory of 2 points, implying that I need a vertical line and a horizontal line to find my point. So here is my vertical line 2, or 1 point. I now need to look, where is my horizontal line 2. So here's 1 and 2 on this side, and I follow it across. There's 1 and 2 on this side, and here is where point 2 will intersect, giving me my point. I do the same process on the other side. My 1 point is the vertical line coming up. Here is point 1, and I follow to where they intersect, and that will give me my point 1 and point 2 on the other side. The last point I need to find is point 3. Now point 3, where it intersects on this main pipe, is at this point. So we've got the height measurement of our 1 point, the theory of 2 points. We now need to find where it touches this point. Now that point is along line C. So at line C, I follow that up, or can I just label it so it's C and where 3 is, and I follow it up to where it hits that intersection, and that gives me point 3. So the hole over here in that shape is where I would have an opening. I'm now going to go over all these lines in an outline. I have the outlines. These lines would be drawn in. They are referred to as fold lines. So where that triangle would be bent, join a point 2 to 3, 1 to 2, and 1 to 3. And there we have the development of our main triangular prism. For the development of the branch pipe, what I'm going to do is I'm going to take the width dimension, and I've projected that across so I can use those actual measurements. The last point is over here. Now if we follow those width measurements, that would give me 1 and 2, and this would be 0.3. Now what we need to do is mark off the length of the side of that triangle. 0.1 to 2 is the true length, but we could also take it off any of these points here in the front view. So I need to take that distance with my compass. I suppose you could measure it as well, and I'm marking that off. There's one side 2, and 3, and drawing my vertical lines. Now let's work out, using the principle of the theory of 2 points. So I've labelled my development. So at point 1, the start of the point is here. Where does point 1 finish? It finishes over here. So there is where point 1 ends at the top. The same, obviously, where it needs to join again on the other side. Now, point 3 is over here. And we can follow point 3 across. There's the lowest point, point 3. And this is where point 3 hits at this height level. Point 2, here is point 2, and it hits at this point. Now, the only thing that we're missing is that 1 to 2, so 1 to 2 has this shape cut out of it. So we need to get this measurement. So going from 1 to 2, we need to find the center of the shape and join up this line. So it's about 15.5. And what's that doing is giving us this little turning point as this top edge goes around the triangular prism. Okay, so the turning point here. So point 1 joins to the turning point, to point 2, to point 3, to point 1, and then completes on the outside of the shape. So there you have the completed development of the branch pipe, the completed development of the main pipe, our front view, our top view, and the left view showing the curve of interpenetration.